Let us move to derivative of trigonometric function by using first principle. With derivative of sine x by using first principle. So let us check the derivative of sine x by using first what? Principle. So to start, for that, if y equal to what? Sine x, you want to know the what? Derivative of sine what? Sine x. So if y equal to what? Sine x, you can call this equation what? Equation what? Equation 1. If you could still remember in normal general first principle we have done before, that we will add a small increment to the y and add it to the what? To the x. By adding a small increment to the y, we have y plus small increment, which is changing y, equal to what? Sine x plus small increment of what? Of x. This is the question given. Find the derivative of sine x by using first principle. So to use first principle to differentiate sine x, we will add small increment to what? To y. The small increment is changing y. Add it to the what? To this y. Add small increment to the x, which is changing x. That leads us to the what? To this. The next thing is you will make this small increment of y changing y as subject of the equation. By doing that, I'm going to have change in y should be equal to what? Sine of x plus change in x. This y will come down here, it will become minus y. So when you have this, now from equation 1, they divide y for us as sine x. Since y is sine x in equation 1, substitute for what? For y here. You can call this one what? Equation what? Equation 2. Substitute for y in what? In equation 2. You will now have change in y equal to what? Sine x plus change in x minus what is y now from equation 1? Sine x. So from this level, I now introduce what we call product formula from the trig. You can check my video on what's on the trig. Product formula. From product formula, we can now say recall that what? If we have sine p minus sine q, it will give us what? 2 cos p plus q over 2, then sine p minus q over what? Over 2. So from this expression, you can now see that what? Everything you have here equivalent to p. Everything you have here equivalent to what? Sine x. This is minus between them. Abi? That's what? Let equal to what? X plus change in x. X plus what? Change in x. And q equal to what? X. So this expression, sine x plus change in x minus sine x. So this sine is this. This sine is this. Everything you add there equivalent to the p. This sine is this. X equivalent to the what? To the q. So once you agree that, you can now move to what? This change in what? Y should be equal to, everything we have here is equal to 2 cos by 2 cos p plus q. Please, what is my p? P is what? X plus change in x. That is p. What is q? The q here is what? X. I've said it here before now. Q is what? Is x. Everything over what? Over 2. Good. Then we are left with what? Sine of what is p? X plus change in x. What is q? Q is what? Is x. Everything over what? Over 2. Everything over what? Over 2. By solving further, we have 2 cos x plus x, 1x plus another 1x. This will give us what? 2x plus change in x, everything over what? Over 2. Then here we have what? Add this together to, we have sine. This x plus x minus x will cancel each other. We are left with what? Sine change in x over what? Over 2. From this expression now, I will now decide to divide what? Divide both sides by changing x. So by introduce changing x to what? To this expression, what are we going to have now? We are moving towards changing y over what? Changing x will be equal to everything you have over changing x. Start from the what? 2 cos angle of what? 2x plus changing x over what? Over 2. And sine angle of what? Changing x over what? Over 2. Everything over what? Changing x. We divide this equation by what? By changing what? X. After that, I want to remove these 2. What are we do? I said, let's divide both. So divide the both numerator and denominator by 2. That is, everything you add up, divide by 2, down, divide by 2. By applying the principle, we are going to have change in y over change in x equal to the what? 2 cos 2x plus change in x over what? Over 2. Sine angle of change in x over 2. Everything you add there, divided by 2. Then our long division, change in x divided by 1 divided by 2. I divide everything we have up here by 2. This one also by 2. In order to eliminate this what? These 2. So the next step is what? dy. The x will be, these 2 will cancel these 2. We are left with what? Cos angle of 2x plus change in x, everything over 2. Then we have sine angle of change in x over what? Over 2. Then over what? Change in x over 2. You know these 2 have gone. We have this with this. Good. The next thing that we have now is, I want to rewrite this expression. By rewriting the expression, like we have change in y over what? Change in x will be equal, it's the same thing as what? Cos 2x plus change in x over 2. If I rewrite it, it will be as what? Dot sine angle of change in x over 2 over what? Change in x over what? Over 2. Do you agree with me that this statement is same thing with this? I just take this out and I put under this alone. Do you agree that what? This statement is the same thing with this one? Yes, if you agree, from the mathematical theory or what? Expression, there is a rule. Now say what? Recall again from trig. Whenever you have sine angle of x over a divided by what? Or let me say sine angle of x over a divided by what? X over what? Over a. Or you have sine angle of what? Of 30 divided by what? 30. It will give you what? This will give us 1. It's not much to be what? To be this. You can have it in this form. Sine angle of what? Of 30 over what? Over 30 is a rule to give you what? 1. Sine angle of the number divided by what? Divided by that number is what? Is 1 from the trig what? Identity. So everything you have here is equal to what? 1. So as a result of that, we are moving to what? dy, the x here will be equal to cos angle of 2x plus change in x over 2. Everything you add here now is equal to what? 1. If everything you add there is equal to what? 1. This expression, I can rewrite it to be in this form, that dy, the x will be equal to the what? Cos angle of what? Here will be 2x over 2 plus change in what? Change in x over what? Over 2. Good. So this cancel this. We are left with what? The change in y, change in x equal to the what? Cos x plus change in x over what? Over 2. You can now say what? dy, the x limit that change in x tend to 0 be equal to cos x plus what? 0 over what? Over 2. At the end of the day, therefore, we have dy dx should be what? Cos x. This is the what? The derivative of what? Of sine x. Whenever you are asked to find the derivative of sine x, the answer is what? Is cos what? Cos x. So if you have to prove the derivative of sine x, show that the derivative of sine x is cos x by using first reciprocal.